Good morning, all of you. Now, today we are going to solve the example from the chapter number lenses. Okay, so from the exercise, we are going to solve the examples. So, example number one question I am reading here. Doctor has prescribed a lens having power plus 1.5 diopter. So, what will be the focal length of the lens? What is the type of the lens, whether it will be concave or convex, and what must be the defect of vision, means which type of defect is there. Okay, so we will solve now this example. uh, in the question, doctor has given a lens, okay, that is having power 1.5 diopter. Okay, so p is equal to given 1.5 diopter. Then we want to find f, okay, focal length. So we know that the formula p is equal to 1 upon f in meter. Okay, so can I write this as f into means this will f will go in the numerator and p will come in the denominator. Okay, so that will become f is equal to 1 upon p. Now put the value of p, that is 1.5 is equal to 1 upon 1.5 diopter. Okay, now this can be written as, because we know that when this decimal point will be removed, then 0 will come in the numerator. So I can write this as is equal to 10 upon 15. Okay, so if you simplify this, means 10 divided by 15, so you will get 0.6667 meter. Okay, or it can be written as we know that we are written 6, so this we can write as 6.67 meter. Okay, so this is positive 0.67 meter. Okay, so focal length is given as positive. So as we know that when f is positive, the lens is convex lens, so focal length in convex lens is taken as positive, and focal length in concave lens is taken as negative. But here focal length is positive, so we can say that this shows that lens is convex. So and the defect is farsightedness. Okay, farsightedness means the person can see the far things clearly but not able to see the nearby things. So this is also called as hypermetropia. Okay, now come to the next example. What is that example? We will see 5 centimeter high object is placed at a distance of 25 centimeter from a converging lens of focal length of 10 centimeter. So determine the position, where it the position of that object, size and type of the image. Okay, so size, how much, what is the height of that, and the type of the image, whether it is virtual or real. Okay, so what is given now? See, 5 centimeter height of the u is given 5 centimeter. Okay, u is given, so I have written here u is equal to, and as we have seen in the that sign convention, the left side that is taken as negative, so u is equal to minus 25 centimeter. Then height of the object is given h1. Okay, h1 is, we have taken 5 centimeter. Then we have to find v. What is v? V is nothing but the distance of the image. Okay, distance of the image, and height of the image we have to find. Okay, height of the distance of the image and the height of the object, height of the image. So as we know that the formula is equal to 1 upon f is equal to 1 upon v minus 1 upon u. Okay, so this can be written as 1 upon v is equal to 1 upon f. Okay, and this will plus, this will go this side. Okay, 1 upon v 1 upon f plus that minus will become plus, so that plus 1 upon u. So this can be written as in this manner. Now we want to find now one v. What is v? So put the values now. What is 1 upon f? What is f here? F is given 10 centimeter, so 10 I am writing, plus as it is 1 upon, then what is u? That is given minus 25 centimeter. Okay, so I have written here minus 25. This can be written as 1 upon 10. This minus we will bring here minus minus upon 125, 1 upon 25. Okay, now bring do the LCM of this. Okay, so we will do this LCM, take out the LCM of these two by the factorization method. Now I have written here 10 and I have written 25. Now what are the factors of or which by which number it is divisible? 10. That we can write the factors 2 into 5. 2 5s are 10. Okay, then 25, the factors are 5 into 5, 5 5 is a 25. Okay, now which are the common digits here? 5 and 5, so I have written here 5. Okay, 5 and 5 common. Now which are the uncommon? 2 and 5, so 2 and 5 I have written. Now multiply these. What is the answer of this? 2 5 is a 10, 10 5 is a 50. So now 50 will be the LCM of this. Okay, now just divide this. 10 5 is a 50, 10 5 is a 50 minus as it is, then 25 2 is a 50. So this we got these two digits, 5 minus 2, then that is 3, 50 as it is. Now this value we got, that is 1 upon V. Okay, this is go 3 upon 50. This is because of value v, because this value is 1 upon V is equal to 3 by 50. Now I am bringing this V in numerator, so that will become V is equal to, the 50 will go in the numerator and 3 will go in the denominator. Now if you simplify this, so we will get 3 ones are 3 ones are, and then that is answer will be V is equal to 16.67 centimeter. So this we got the distance of the image. Okay, this 16.67. Now we want to find, we have found the value of V. Now we want to find the value of V, H2. So H2, we know the second formula of this, H2 upon H1 is equal to V upon U. This can be written as H2 is equal to V into H1, V into H1 upon U. Okay. Now put the values of this. Now see here, what one thing I want to tell you. Instead of this value of V, we are taking this value. Okay, for so that our simplification will be simple. Okay, now put the values in this. So the values H2 is equal to 15 upon 3 upon minus 25 into 5 centimeter. So this can be written as 50 upon 3 into, now 1, this will come in the denominator. We can write this as 1 upon minus 25 into 5. Okay. Now is equal to, now we simplify this now. So it will become now minus 50 upon 3 into 1 upon 25. Okay, this 5 will be written in the numerator. Okay, 5 upon 25. So now just simplify. 5 5 is a 25, 5 10s are 50, then 5 1s are 5 1s are 5. Okay, if you just multiply this, this will become minus 10 upon 3, minus 10 upon 3, that will be. So if you simplify again, that will become minus 3.3 centimeter. Okay, now the height of the image we got, H2 is equal to minus 3.3 centimeter. So from this we can say that if the height is, or the height, if the height of the image is in minus, so we can consider that the image is inverted and it is real. Okay, so this is image is inverted and real. So the answer you write, the image is real, inverted and smaller than the object. Why? How smaller than the object? Because we know that u was minus 25 centimeter. Okay, then we got in the 3.3 centimeter. Okay, so that is, no, actually the distance is that is the distance. Height of the object was 5 centimeter. So what is the height of the image? We got minus 3.3 centimeter. So we can say that it is smaller than the object. Now third bit or third question of this example. 3 lenses having power P is equal to 2, 2.5 and 1.7 diopter are kept touching in a row. what is the total power of the lens in the combination. Okay, so we can consider that p, that 2 is nothing but p1 we will consider. Okay, power, or p power 1, power 2, power 3. So p1 is equal to 2 diopter, p2 is equal to 2.5 diopter, and p3 is equal to 1.7 diopter. Okay, so we know that the formula for that, the average, that will be p1 plus p2 plus p3. So p is equal to p1 plus p2 plus p3. Add all this, so you will get the total power of the lens in combination. Okay, so that is 2.2 plus 2.5 plus 1.7, that will be 6.2 diopter. So this is the answer. Okay, now come to the last question of that example. What is that? An object kept 60 centimeter from a lens gives a virtual image 20 that is 27 centimeter in front of the lens. What is the focal length of the lens? Is a converging lens or diverging lens? They are asking that we have to find the focal length of the that lens, whether it is a convex lens or concave lens. Okay, so converging means concave lens and diverging means concave lens. This is convex lens. So an object kept means the distance. Okay, we know that the distance is given 20 u is equal to minus 60 centimeter, and v is given. Okay, v is also given here. We want to find the focal length, so v is equal to minus 20 centimeter. As we know the formula, f is equal to 1 upon v minus 1 upon u. So we want to find focal length, so we will put the values here. 1 upon v, that is to minus 20, minus as it is upon 1 upon what is u, that is minus 60. So this can be written as, we are writing this common minus, we have taken outside, then 1 upon 20 minus 1 upon 60. Okay, we have taken. Now to take out the LCM of these two, what we are doing, we are just taking the factors of this 20 and 60. So it is divisible by this digits 2 into 2, that is 4, 4 5s are 20. So 2 into 2 into 5. And what are the factors of this 60? 2 into 2, that is 4, 4 into 3, that is 4 3s are 12, 12 into 5, that is 60. Okay, so now just see what are the common in this. First is the 2 common, so we have written 2 here, or here we have written 2. Then in this, these are 2 common, then we have taken one uncommon is there 3, and these are the common. Okay, so 2 and 2, 3 and 5. So these are the factors. Multiply this. 2 2s are 4, 4 3s are 12, 12 5s are 60. So 60 will be the LCM of this. Okay, 60 I have written. Now this is 20 is divisible. 23s are 60. 23s are 60. We have written 3 minus as it is. Then 60 ones are 60. 60 ones are 60. So I can write this as minus as it is 3 minus 1, that is 2 upon 60 as it is. Okay. Now divide this. 2 ones are 2, 2 threes are 6 and 0. That is minus 1 upon 30. Now as we know that this is the value of 1 upon f. If what f is equal to, that is if you bringing this f is in the numerator, this will also come in the numerator. Okay, so f is minus 30. Okay, so focal length is given minus 30. As we know that the focal length is negative in case of concave lens. Okay, so as the focal length is negative, so it is diverging lens. Okay, we know that converging lens is nothing but convex lens, and diverging means concave lens. So as that is in negative, so we can say that is a concave lens, and it is in that is the diverging lens. Okay, hope you understood all the example. Thank you.